So in this question we are provided with the ionization constant of the dissociation constant of phenol, which is 1 into 10 to the power minus 10. Again this is 10 to the minus 10, that means it is much more less than 10 to the minus 3. So the reaction is just started. So it has been asked what is the concentration of phenolate ion in 0.05 m solution of phenol. This is the part 1. And the part 2, it is asked what will be the degree of ionization if the solution is also 0.01 in sodium phenolate. So two parts. Let's in the first part we calculate the concentration of phenolate ion. So when phenol dissolve in water, it will produce phenolate ion and hydronium ion. So as per the question, the initial concentration of phenol is 0.05 and the concentration of hydronium ion and phenolate ion will be 0. At equilibrium, let X amount of phenol dissociates to produce ions. So the concentration of phenol will be 0.05 minus X, and the concentration of phenolate and hydronium ion will be XX. So if we write the expression for K, it will be the concentration of phenolate ion into hydronium ion divided by concentration of phenol. If we put the values, it will be 10 to the minus 10 is equal to x square divided by 0.05 minus x. Again, as the K value is very small, so we can say the value of x is very small than 0.05. So 0.05 minus x is nearly equal to also 0.05. So by solving the equation, it will give x square is equal to 5 into 10 to the minus 12. Now we have to find the square root of 5 into 10 to the minus 12. Again we can write this as 500 into 10 to the minus 14. Now we can find the square root of 10 to the minus 14, which is 10 to the minus 7. And to find out the square root of 500, we have to use some general math instructions, like the square of 22 is 484 and the square of 23 is 429. So it must be in between, and it seems like it is the in middle of 22 and 23. So let's try for 22.5. The square of 22.5 is come up as 506.25, which is very near value. We can take it. So the value of x is nearly equal to 22.5 into 10 to the minus 7, or you can say 2.25 into 10 to the minus 6. So the concentration of phenolate ion, which is x, is equal to 2.25 into 10 to the minus 6 m. M means moles per liter. So in the second part, it has been asked the degree of ionization if the solution is also contains the 0.01 m sodium phenolate ion. So as it contains phenolate ion, the sodium phenolate will dissociate into sodium phenolate, ion and sodium ion. It is a strong electrolyte, so it will produce same amount of the phenolate ion and sodium ion. So we can say this sodium phenolate ion will completely dissociate to produce this phenolate ion and sodium ion, and this phenolate ion concentration now will be 0.01 before starting the reaction. And as per the question, the concentration of phenol is 0.05. So let alpha amount of phenol dissociates. So the concentration of phenol at equilibrium will be 0.05 whole into 1 minus alpha. So now the concentration of phenolate ion is 0.01 plus 0.05 alpha, and hydronium ion will be 0.05 alpha. If we write the expression for K, it is same as per the above. By putting the values, it will be 0.01 plus 0.05 alpha into 0.05 alpha divided by 0.05 whole into 1 minus alpha. As the value of K is very small, we can say alpha is much more less than 1. So 1 minus alpha is nearly equals to 1. Similarly, 0.01 plus 0.05 alpha, this value will be nearly equals to 0. So this will become 0.01. So again, substituting these values, the alpha will come up as 10 to the minus 10 divided by 0.05, because 0.05 will cancel out. So now solving this, alpha becomes 1 into 10 to the minus 8. So this is the degree of ionization when the 0.05 m phenol also contains 0.01 sodium phenolate. Thank you. Happy learning.